right now it's gonna be right here, right? So if I do it, I'll try to make all of these nails balance on that. So did this part balance. This is a center of gravity. I put equal weight on each side to make the center of gravity.
So now you are able to balance the nails on one.
So I'm going to do. So I'm going to show gravity pulls stuff down, and now inertia makes stuff keep going. So this is Bob. He doesn't put his seatbelt on when he drives. So I'm going to put him here, and he's going to go down. Gravity's going to keep pushing him down. He's going to go like this, and inertia is going to make him fly off, and gravity is going to push him down.
Oh, he must be having a seat belt, very good seat belt. That's why it didn't pop out. Yeah, not tied the seat belt properly. What is inertia?
Inertia is a force that keeps pushing an object until an outside force stops it.
इनर्शिया वो नहीं होता इसमें बैठा रहता है.
Change high pitch and low pitch by the thicker string and skinnier string. The skinnier string is gonna make a higher pitch, and the thicker string is gonna make a lower pitch.
And why is it so?
Because this it's skinnier, so it can make more vibration, so it makes a higher pitch. And so if you do like push it down, it's gonna make a higher pitch. And if you do it here, it's gonna make a little higher pitch.
Lower pitch.
No, high. It's a little higher.
Low vibration.
And that's because now there's less. So now it's stopping it so it can travel faster, and when it's traveling faster, it can make higher pitch.
Too much of science for me. Okay.
With using both of all three of these things. So you're supposed to try.
She will try. Thora, make it quickly, Didi.
Yes. And then done.
So what with this?
So this is a path which makes the electricity pass through. Since it's a conductor, the conductor lets electricity pass through. And so this is a source. It makes the thing happen, and this is a job. It tells what's happening. So the job is the light bulb lighting up, and the source is a battery, and this is a path.
So okay, let's remove this. Now light. Can you light it? The light bulb?
Yeah.
No. With this source. Can you lit the bulb with this on this board?
No, see?
But why?
Because it's an insulator. Insulator doesn't let its electricity pass through.
Oh.
In Mexico or Japan, they're making a train they're making a bullet train which can go faster, so they're using magnets.
Okay.
So pretend this is a bullet train. The track is down there. So this is what they did. A track is when magnets get together like that, and this is repel is when they separate. They can't go together because north and north can't go together, and south can't either. And if you do the opposite, then they can only. So they made something like they put this thing here. Yeah. So it's like they did we put the opposites. So like this, and it's gonna bounce up so it doesn't. See, it's not really touching the track.
ओ इसका मतलब बुलेट ट्रेन जो है it doesn't, it's not touching the tracks, वो ऊपर रहती है and it's using this
So
principle.
it's using less friction.
Oh, that was my
So
next
less
question. So what
friction,
is the benefit?
less friction makes things go faster. Less friction makes heat, which makes things slow
What
down.
will be the problem if the friction is more than what? Speed, I understand. Okay, but
Friction,
Otherwise-
it's gonna make it slow down.
oh, so then we need to put more energy to make it go fast. Okay.
And you need to put
What's that? Oh,
So side.
the वो magnet are on the sides. Get it. That looks complicated. What it is?
it's a circuit. So a circuit, do you think it will light up? So if I take a battery and if I touch this one down too, do you think it will light up?
Yes.
Why?
I don't know. Why?
It will, because these are conductors.
So why is it lighting up? Why is the bulb lighting up?
Because it's a conductor. Conductors let electricity pass through.
And then what happens?
And then the electricity goes in here and it lights it up.
Okay, so but what you are showing us here? Because we already saw one circuit.
Yes.
There,
So
right?
it lights up, right? So now, do you think it will light up if I touch this? And if I put this down, do you think it will light up?
Yeah.
Why?
Yeah, there is still electricity pass.
So it is a conductor, right? You're wrong.
Yeah, let me try.
It's an insulator.
Wait.
Stop cheating.
See this?
Stop cheating. I knew you would. The teacher said so that you would cheat. Fine.
So what you can do is.
Fine. I have an idea.
Yeah. Now it will not work. See, you have to show like this. So there is no point left for
So it
cheating.
can't.
Yeah.
Why?
It's a metal
And a metal is
conductor.
you're wrong. It's an insulator.
Metal is a conductor.
You are cheating.
You already saw the one point.
So it's gonna light up. Correct.
Why is that one not lighting me?
Because it's an
That was a metal
insulator.
thing, huh?
It's an insulator.
But it has a metal.
We never learned that. Correct.
Because you are doing a cheating.
This is these one is north and one is south. Okay.
Which
So
one is north, which one is south?
you can't tell it. They're gonna be the same. So if you do this, it's look. See, if you touch it, it's gonna fly, right? Okay, it's gonna fly, right? It's gonna go up. But if you don't touch it, will it go up? Why? Yes, the magnetic field is around a magnet, which can also make it go, which can also make it go, like fly up. See, so you try to get it to your highest without touching the field.
No, I don't understand. What is
Someone
magnetic
got it
field?
here.
Me? What's magnetic field?
Magnetic field is the outside of a magnet, which acts like a magnet, and they can still let things attract to it.
So do you remember you did one practical with Didi about this magnetic field and you drew something? Rishka, do you remember you did one practical or project on this magnetic field? You drew something, one chart and graph where all the magnetic field is.
Can you Miss Stacy?
Hi. How are you? I'm here to see you.
Do you think if you put this in light, do you think light can pass through?
What was your question?
If you put this in light, do you think light can pass through?
Yeah, it depends
No.
whether it's transparent or opaque.
It can pass through very little. If you try, you'll still get some light on your hand. And do you think, so this is translucent. If you put this up here, do you think light can pass through? It can pass through really clear, so this is transparent. If you put this up, will it pass through?
Yeah, if I'll make a hole in this.
It can. So this is opaque.
Okay, Neil, how did you learn those terms, opaque and transparent and all? Can you tell?
I made up how to remember opaque because you need to open it to see through.
Okay, and transparent?
And you need a parent's help to look through it.
No, parents know everything. So that's why it's a very transparent. That's how we learn those terms.
And what about translucent?
It's gonna be really hard to pull it. So that means it has more friction. Friction is when two things rub together and they make heat, so this is gonna be harder. It makes more friction. So do you think it will make more friction or less friction?
If you put this under the books, less friction.
Do you think it will move faster or slower?
No idea.
Okay, so rub your hand.
Okay. She's doing. You get
Rub
it.
your hand together. Like heat, right?
Yeah.
Rub it with your mouth right? That means this makes less friction. So if you put this hard and easier to move. So it's gonna be like, it's gonna be less friction. It's gonna make noises when I put the sponge here and pull it. It makes noises because of the friction. It rubs together, so it makes vibration, and the vibration makes sound waves. And so this is a resonator, which makes volume louder. So if you do it, it's gonna get louder.
So what if I put a
What
smaller
is
or
a
bigger cup?
resonator?
Then if you put a smaller one, it will make a little less volume.
Why less? Why less?
Because it's a smaller resonator.
What is a resonator?
Something that lets air go through and move around.
Really?
So if I put this here and you blow really hard and fast, will it go through or come out? Why?
Go inside.
Try. Hey, blow hard and fast.
So if it comes out, then okay, otherwise it's out.
Did he do it, Neil?
No, you pushed it slowly.
Oh, I told you, these dads try to cheat. They're always doing that. There you
Oh! Really?
I want to hear the explanation.
Yeah, Neil, what's the reason?
It comes out because when you blow in really hard, so much air comes in that it comes here and bounces back, that it makes the paper come out.
And what if we do it like slow?
Then it's gonna go in because there's less air. So it's gonna bounce.
But if we blow for like long times,
It's gonna stay in.
So maybe the bouncing of the air is not that fast.
Yeah.
That is why
The air takes up space and that air is, it's also going to show that air is lighter than water. So I'm going to take this cup, fill it with water, and flip it over so it's full with water. I'm going to take this one, push it down slowly so it got filled with air. So if I push this up a little, and get this closer and lift this up, the bubbles are gonna go up. That proves that air is lighter than water because bubbles are made out of air, and so it also will prove that air takes up space. Okay, like this. So I'll take this one out. So now if you look down, can you see that?
Oh, the air got into the other
Yes,
one?
right. No, the air is right here.
Yeah,
on
I
the
see
top,
that.
and the rest
Yeah.
is filled with water. So that air is lighter than water because the bubbles are going up and not
Those bubbles
down.
that you saw were the air. Was the air.
Mirror and write your name correctly. So this is like this. You're supposed to look in the mirror and write it correctly. So if it doesn't look correct in the mirror, then that means you're doing it wrong. So you need to write your name correctly in the mirror.
So what is the science behind it? That's just a game.
That it reflects back. No, it won't look the same unless you do it correctly.
So this nail is not looking the same inside the mirror? Oh, okay.
तो मुझे यहाँ पे उल्टा लिखना है उसमें सीधा दिखे ऐसा लिखना है
You can write it any way you want to, but it's supposed to look correctly in there.
हाँ ओके
Here, you can balance it. So it's going to be right in the middle. Right there. So, if you take it off and you put one, the center of gravity.
What is center of gravity?
The place where gravity pulls down mostly.
Good job, Neil. Now you said the correctly.
So it's gonna be more like here on the other side, like there. So it wasn't in the middle. So change the center of gravity. So if you put one here,
So you can put as many clips.
so if you put one there and change the pitches, so like a squeak, a really high squeak.
Can you say again, please? Repeat.
A high pitch is where a really loud squeak comes, and a low pitch is where it sounds like an elephant, but it sounds like lower. So if I hit this, do you think it will make high pitch or low?
Hi.
Okay, so it didn't make high pitch. That it made a high pitch because there's more space for
Oh, the singing grass.
sound waves to go around and vibrate, and the vibration will make more sound. And if you go here, it's gonna get more to a lower pitch.
Mommy?
That's because there's gonna be less space for the sound waves to move around.
What is it that you are trying to do, Neil?
Make a
Are you
pitch.
cleaning the this?
Glass.
Maybe.
Hmm?
Are you ready for it?
Can you explain what it is doing and why it is doing?
What is the science?
So if you do it, this is a resonator. So if you like when you do it, it makes vibration, which makes the sound waves go here. So it's gonna make a high pitch and low pitch.
So you can jump in this one, because you've already had this one. That's why we
But it's a little easy.
He's memorized. Look at that. And if you have different levels of water, the glass will make a different tone.
Like this.
So you can actually, these are just regular glasses, but the crystal are really better. And if you have 3 different levels, you can actually make different